Hi, welcome back. Yesterday we studied about hydraulics and pneumatics introduction along with the basic components of hydraulics and pneumatics, followed by a very important law which is called as Pascal's law. Moving on, today we are going to study a very important topic called as hydraulic fluid. So, hydraulic fluid is the basic working media in any pneumatic and hydraulic systems. Today I am going to cover all these topics, that is hydraulic fluids, additives, effect of temperature and pressure on hydraulic fluids. So, the learning objective is very important. So, we need to understand what is the aim of this study. To examine the technical as well as commercial properties of any hydraulic fluid. So, the first objective is this. So, we are going to study in detail what is the technical property as well as the commercial property for a viable hydraulic fluid, which is used for power transmission. Nowadays, we are having so many hydraulic fluid, how to increase the efficacy or efficiency of these oils, then we need to add some additives to that. So, we need to know about the different additives, their properties, their function. So, we need to study about them. So, we are going to explore different types of additives used in typical hydraulic and pneumatic systems. So, this is the overview of my lecture. So, the first will be the fluids for hydraulic system, followed by the different types of hydraulic fluids. Next is properties and selection of an hydraulic fluid, additives, effect of temperature and pressure on hydraulic fluid. So, different types of hydraulic fluid used. So, the first and the most important fluid is water. So, water is abundantly available, it is of low cost and we can use that as one of the prime hydraulic fluid. In fact, it is the first hydraulic fluid which was used for power transmission. Some of the reason for why water is being used are, it is less expensive, it is abundantly available. So, we cannot use raw water as it is, we need to subject that water for certain special treatment before using it as an hydraulic fluid. So, we need to add certain process. One such process are filtration followed by chemical treatment before using it as a working substance in any hydraulic and pneumatic systems. This special treatment will remove the undesirable material available in the water. So, water is the first and the easiest source available. Next, we use petroleum oil. As we know that petroleum oil comes under non-renewable sources, water comes under renewable resources and petroleum oil comes under non-renewable resources. So, these are depleting, but still we can use petroleum oil as long as it is available. So, it is a fossil fuel oil available from generations. So, these are commonly used hydraulic fluids in different automobiles and different industries having different viscosities. Wide range of hydraulic oils are available nowadays and it is easy to synthesize this artificial oil. So, basically the characteristics of any petroleum oil is based on crude oil from where it is derived. So, petroleum, even though it is depleting, it is still used today because of its viscosity characteristics. Next, we move on to water glycols. So, what is this water glycols? These are solutions containing 35 to 45% of water. They can be thickened, you can have thinner to it and you can thin it, right. So, this is used to improve viscosity. So, this speciality of water glycol is water has limited viscosity, whereas water glycol has improved viscosity because you are adding certain amount of soluble agent to that, so that the viscosity of the water increases and lubricating properties will also increase. The next, water oil emulsions. So, these emulsions are new inventions in this field of hydraulics. As we know that we are using emulsions for painting purpose, and these emulsions are water soluble, and there are two types, oil in water and water in oil. See, these emulsions are very popular because when they are mixed with the water or oil, right, they form the dispersed medium. So, the first type is oil in water emulsions, where water as the continuous base and oil is the add-on in the dispersed media. The next is water in oil emulsion, where oil is continuous and water is added. So, you can use both the type. So, I will give you a simple example. We can relate this to paint. So, paint also we are having two types. One is the oil based paint and another one is water based paint. So, oil based paint is having oil as the main base, whereas water based paint water as the main base. So, both are having different application. For metallic and wooden surfaces, we go for oil based paint. For ceramic and wall concrete structures, we are going to paint using the water based paint. And oil based paint, because of the presence of the oil, the cost is very high compared to the water based paint. So, which is economical depends upon the function. So, this is the oil in water, this is the water in oil. So, you can see the difference, it is just dispersed and floating. The next type of is the phosphate ester. So, this is also a hydrocarbon which is got by the esterification of the phosphorus, so into organic molecules. This speciality of this phosphate ester is that it is having high thermal stability. It is having high thermal stability. Hydrocarbons like petroleum, they disintegrate when subject to high temperature. So, that shortcoming is overcome by adding phosphorus. So, this phosphorus reinforcement enhances thermal stability. So, you can use this hydraulic oil for special application like high temperature application, particularly if you are using this oil in countries where tropical countries where the temperature is very high or in deserts. They serve excellent characteristic like detergent and prevent the formation of sludge. So, this is a typical chain of phosphorus. So, the phosphorus is the center molecule followed by oxygen, hydrogen. Continuing with the next, we have the important, still now we have studied about the different types of fluids which can be used as a typical fluid in case working substance in case of hydraulics and pneumatics. Now, we need to check very important properties of these fluids. So, the first important property is viscosity. So, viscosity is nothing but resistance to flow. The literature says that viscosity is resistance to flow, or the resistance offered by one layer of fluid sliding over the other layer. It is the measure of fluid's internal friction. So, one of the important property related to viscosity is that viscosity index. So, we know that an oil can be used for different applications as a function of temperature. So, an oil can be used for high temperature as well as low temperature. So, the viscosity should be constant and it should not be altered under extreme temperature condition, and this is called as the viscosity index. So, the viscosity index should be flat as far as possible within the acceptable temperature range. We know that the viscosity of the oil decreases with the increase in the temperature. So, we need to arrest this phenomenon as far as possible. We need to prolong this decrement as far as possible. So, that is called as the viscosity index and its effect. The next property which is very important is the deemulsibility. So, deemulsibility, the emulsibility is nothing but dispersion of the hydraulic fluid. So, deemulsibility is the reverse of that. The ability of the hydraulic fluid to separate rapidly when it comes in contact with moisture is called as emulsibility. It is known to resist emulsification, right. So, this is very important because we need to store the oil in a container or a reservoir for a longer period of time. So, if the hydraulic fluid does not possess the required deemulsibility, so it becomes strong and sludge is formed. The next important property of the hydraulic fluid which is related to viscosity is lubricity. So, lubricity is very important. It is the ability of the hydraulic fluid to permit smooth relative movement between two layers. So, this is called as lubricity. So, lubricity is similar to lubrication. So, lubrication is associated with lubricants, whereas lubricity is associated with the hydraulic fluids. So, lubricity is generic in nature, whereas lubrication is specific in nature. So, very important properties these two, deemulsibility and lubricity. So, the next properties is flash point and fire point. We know that these 2 points are very important. So, what is this flash point and fire point? So, in flash and fire point, it is the temperature point at which the hydraulic fluid catches into fire. So, it is called as fire point. The next is the point, the temperature point at which the hydraulic fluid turns into momentarily flash. So, this is called as flash point. So, both points are very important because they represent the ignition temperature. So, we need to operate the oil below the ignition temperature, otherwise lot of complexity is created. So, one such complexity is the oil itself will catch into fire, right, or the oil will start flashing and the flames are produced. So, both are unwarranted phenomena. The minimum temperature at which the fluid will catch into fire is called as fire point, and the corresponding point where it produces momentarily flash is called as flash point. So, this is very important, and usually the flash point is below the fire point. So, fire point is the final point, and below that fire point flash point is there. So, first flash point is attained. If you keep on continuously increasing the temperature, then the fire point is attained, and the lubricant itself or the hydraulic fluid itself will catch into fire. Next, pore point. So, the next important property which into consideration is the pore point. So, pore point is a very important property because the pore point is the ability of the hydraulic fluid to cease to flow. So, we know that, I will give you an example. In winter season, if you are using a coconut oil, the coconut oil crystallizes and it becomes white jelly. So, you find it very difficult to dispense it from the container. So, as a result, what we need to do is we need to keep that inside a hot water bath. The temperature heat transfer takes place and the crystal melts and you will get back the oil. So, that is called as pore point. So, pore point is very important because it finds its application of the hydraulic fluid in colder countries like Russia, Serbia, etc. So, where the temperature is very cold and the oil itself will crystallize and it becomes a semi solid and it cannot flow. So, once it cannot flow, what will happen is it cannot be transferred from the source to the receiving or application. Next is neutralization number. Neutralization number is similar to pH number. So, we have in pH scale 0 to 7, 7 to 14, less than 0 to 7 is acidic, 7 to 14 is basic, and we have a buffer zone, right. So, similarly, we do not use pH for oil, we use neutralization number. It is a measure of acidity or alkaline of an hydraulic fluid. It is a very important because this number designated will corrode or will react with, if it is acidic in nature, it will react with all the metallic components in the pathway and it may corrode or it may form oxides. So, slightly it should be alkaline in nature. So, alkaline is a condition where neither the hydraulic fluid is acidic, neither it is purely basic. It is something like water, which is neutral. This acidity causes oxidation and results in failure. Next important property is oxidation stability. So, what is this oxidation stability? We know that any hydraulic fluid when exposed to atmosphere reacts with oxygen and compounds are formed, oxides are formed. So, we need to see that the given hydraulic fluid, even if it is exposed to atmosphere, remains inert for a longer period of time. The oxidation of this oil will result in impurities which are carried away along the pipelines and they may corrode the pipelines, the inner wall of the pipelines, and the efficiency of the intermediate components decreases. So, one of the main problem with this hydraulic power system is that the transmission line should be always clean. It should be free from all these dust particles, sludge, contaminants which are generated by chemical reaction of the hydraulic fluid with the atmospheric oil. So, we need to choose an oil which is less active with respect to the atmospheric air. Rust prevention. So, the next important is the rust prevention. The moisture entering into the hydraulic system with air causes the ferrous part to rust. So, rust is a universal phenomenon. So, wherever there is a metallic surface which is exposed to the moisture or the atmosphere, so it absorbs moisture and the oxygen present in the atmosphere, then oxides or metallic oxides are formed, which results in mechanical degradation of the surfaces. So, lot of the same scenario is available to hydraulic systems. So, hydraulic systems are frequently interacting with metallic surfaces. So, if the metallic surfaces are exposed to atmosphere as well as moisture, it also results in contamination of the hydraulic fluid itself. So, rust prevention is very important because it results in the transfer of rust and other oxides to the hydraulic fluid itself, which results in what? The contamination of the oil itself. So, this rust is passed on to critical elements like pumps and other valves in the pathway of the typical components involved in hydraulic and pneumatic system and results in underperformance. So, what is the remedy? We need to add certain inhibitors which will retard the formation of rust. So, the next, density. So, density is very important. It is a very technical quantity and it is the quantity of matter contained in the volume of the given hydraulic oil. So, whether it is compressible or incompressible, whether the density is constant or density is variable. So, this is very important property of any hydraulic fluid. Compressibility. So, we know that all fluids are compressible when subjected to force. So, the liquid acts like a spring. So, it acts like a spring. It provides cushion to the external force. So, the load bearing capacity of any application depends directly on the hydraulic fluid. It is in turn depend upon the viscosity, and it is affected by pressure and temperature variations. Now, after studying all these properties, we need to know what is the desirable property for a typical hydraulic fluid. So, what is the desirable hydraulic property of a typical fluid? An hydraulic fluid has the following primary properties. It should transmit power efficiently. It should permit smooth movement of the relative surfaces, preventing wear and tear, and it should seal the clearance between the two mating parts to avoid leakage. Also, it should dissipate heat because heat is generated when two surfaces are rubbing, and this heat hydraulic fluid will physically separate these two surfaces and the heat is dissipated. So, these are the basic functions of any hydraulic fluid. So, they are used for multifunctional. So, the next important property is good lubricity. So, lubrication is very important because it prevents the friction, wear and tear, the unnecessary phenomenons. Ideal viscosity, actually speaking there is no technical term called ideal viscosity, or we can call it as perfect viscous medium. So, as far as possible there should be a certain amount of viscosity available inside the fluid. Chemical stability. So, any hydraulic fluid should be chemically stable and it should not interact with any other members, internal as well as external. Compatibility with system materials. So, compatibility is very important because we need to match the hydraulic fluid for a particular application. High degree of incompressibility, that is, we need to have hydraulic fluid which is having a constant density throughout its operation. Fire resistance. See, fire resistance is very important because the hydraulic fluid itself may catch into fire sometimes because of low flash and fire point. So, we need to investigate the flash and fire point. For that, we need to conduct rapid tests on the oil samples and we need to find out the flash and the fire point and take corrective actions. Good heat transfer capability. So, the heat dissipation capacity depends upon conduction, convection and radiation. So, these three important modes of heat transfer is governed by different thermal properties like coefficient of heat transfer and the radiation heat transfer and the other properties. Low density. So, density plays a very important role in hydraulic system. So, preferably we should have low dense system. Foam resistance. So, foam is formed by interaction of hydraulic fluid with the rubbing surfaces. So, we have found that whenever there is rubbing between these two surfaces, mating surfaces, foam is created because of the churning action of the hydraulic fluid. So, this is unwarranted. So, the foam will form fludge on the top or the bottom surface and it need to be expelled out frequently. Non-toxicity. So, non-toxicity is very important because if we have a bad smell or the odor, if we keep on continuously inhaling this, it results in health hazards. The next property which is very important is toxicity. So, frequently we are using oil which disintegrate and produce toxic substances. It may be solidus as well as liquidus, sometimes it is gaseous. So, this may harm the environment. So, this is also very important because we need to preserve the environment. So, we need to use oils which are less toxic as far as possible. Low volatility. So, this volatility is very important because this is particularly applicable to cases where we are going to store the oil for a longer period of time. So, oil plays a very important role because we need that oil inside, we need to store that oil in a container for a longer period of time, and if the oil is volatile, the level of the water in the container will drop. So, we need to frequently replenish the fuel tank or the reservoir where it is stored. So, these are the ideal typical properties of desirable properties of any hydraulic fluids which can be employed for power transmission in any systems. So, one by one you can see these properties. So, let us move on to the next important topic called as additives. So, additives are substances which are added to the base hydraulic oil to enhance its properties. Maybe it may be a mechanical property, chemical property or thermal properties. So, additives are added. So, various additives are available in the market. So, we can adopt or we can select or purchase these and we can add it to the base. Some of the important characteristics of additives are, it is anti-foaming. So, when you add an additive, no foam is formed. Next important additive property is anti-wear. So, when you add additives to an existing hydraulic oil, it will improve the lubrication characteristics. So, lubricity will increases. As a result, the wear, friction wear and other associated phenomenon will diminish. So, some of the additives are added to inhibit corrosions. So, this corrosions is a phenomenon which will occur because due to the interaction of the existing hydraulic fluid with the atmosphere as well as the moisture. So, if you add inhibitors of corrosion as additive, so the corrosion process is prevented to an extent. Biocides. So, nowadays we are adding naturally available organic material as additives. So, the advantage is that so no chemical reactions and harmful chemical reactions in particular. So, lot of improvements and research have taken place in this direction and we have lot of additives available. Name the property to enhance it, we are having additives. Now, different types of additives available. First one is emulsifier. So, this is the first additive available, we can enhance the emulsification process. Next one is lubrication oilness agents, flocculants. So, deionization is very important because whenever the oil, hydraulic oil is subjected to temperature variation, it should not result in dissociation of the oil itself. So, splitting up of oil into constituents. So, in order to prevent that splitting, we use deionization, anti-deionization agents. Next is oxidation inhibitors. As we know that whenever an oil is exposed to the atmospheric air, oxidation is formed. So, it results in compounds which are unwarranted, they results in formation of residue and further complications. Vapor phase inhibitors. So, vapor phase inhibitors are added to reservoirs which store huge quantity of oils for a longer period of time, which prevents vaporization of the hydraulic oil itself. Next important property of hydraulic fluid is its effect on temperature. So, a temperature is the main prime characteristics which affects the hydraulic fluid. We, after knowing the different types of additives, we need to know the effect of temperature on an hydraulic fluid. As we know that we are using oil in different temperature ranges, particularly an oil used in India is different from the oil used in western countries like Europe, which is particularly cold, or in Middle East countries where it is particularly hot. So, this oil is subjected to different temperature variations. So, one of the important is parameters which is affected by the temperature variation is viscosity, and the index of this is called as viscosity index. So, viscosity index refers to the ability of the oil to maintain its technical properties in temperature fluctuations. Sometimes temperature has an adverse effect on the viscosity of the hydraulic oil, as we know that the temperature and the viscosity of the oil are inversely proportional. Hence, the operating temperature of the system, hydraulic system, should be chosen in such a way that it produces constant level throughout its working range. Next important effect is the pressure effect. The previous is the temperature effect, now it is the pressure effect. Now, we need to know the effect of pressure on hydraulic fluid. We know that temperature and pressure are interdependent. So, an hydraulic fluid which is too viscous generates more friction compared to the oil which is moderately or less viscous. because of high pressure drop. The other hand, the low viscosity fluid produce low drag characteristics. So, while choosing the hydraulic oil, there is a dilemma that we need to maintain more number of viscosity in case of the hydraulic oil, which results in low drag characteristics. Now, let us watch few videos related to this topic. The first video is all about the different types of hydraulic fluids available. The second video is about the properties related to hydraulic fluid, that is technical as well as commercial. The third is related to additives used commercially worldwide. So, after watching these videos, you will get deep insight regarding the different types of hydraulic fluids. In order to enhance the teaching learning process, as an add-on, I have taken videos from YouTube channel for which I acknowledge the same.
Tractor downtime. We all know what that means, and it's not good. Tractor downtime negatively impacts your bottom line. But did you know that the most common cause of equipment failure is that moving parts are not lubricated properly? If you're not using a high-performance fluid with valid OEM credentials to lubricate your tractors, you could be putting your profitability at risk. With more low-quality fluids popping up on retail shelves every day, it's getting harder to choose fluids that offer equipment superior performance and protection. While you may feel confident selecting a fluid based on its OEM credentials, you need to be cautious, as many lubricants claim to meet the specs, and they really don't.
Adding to this confusion, fluids that can't meet current OEM credentials oftentimes mislead you by advertising only obsolete and outdated OEM specs, such as J20A, 303, and Ford New Holland M2 C134B and C.
To help you identify high-performance fluids you can trust, TractorLife.com has developed a mark called TractorLife.com Authenticated. You can be sure that tractor hydraulic fluids endorsed by this mark meet and often exceed current OEM credentials and performance claims, providing you ultimate protection and performance for your equipment.
So let's take a closer look at OEM credentials. OEM specify physical, chemical, and performance requirements of fluids for use in their equipment. These fluids are designed to provide desired frictional properties for wet brake and clutch operations, reduced gear wear, and other performance characteristics.
However, most OEM specifications are self-certifying, which means OEMs don't provide any real checks on claims that oil companies make on their product labels. We know there are oil companies in the marketplace that claim their fluids meet OEM credentials and performance claims, when again, they don't. To illustrate this point, we tested a low-quality fluid and a high-performance lubricant against a few of the John Deere J20C requirements. The results may surprise you.
Kinematic viscosity measures the thickness of the fluid. The J20C specification requires a minimum of 9.1 units to adequately protect equipment. In the test, the low-quality fluid fell short by nearly 30% at 6.6 units and would not protect equipment as recommended by John Deere. However, the high-performance fluid exceeded this criterion at 9.5 units. Quite a difference.
Now let's look at another physical property in the J20C specification. Brookfield viscosity shows low-temperature performance of a lubricant. At minus 35 degrees Celsius, the specification requires a maximum of 70 units.
The results here will shock you. The low-quality fluid totaled more than 1,000 units, falling well outside the maximum specification and far into the danger zone. Simply put, the low-quality fluid won't perform well in cold weather. In fact, the low-quality fluid doesn't flow at all in the cold temperature. It is clear that the fluid will make it harder to get your equipment started and take longer to provide an adequate lubricant film in cold weather. Meanwhile, the metal parts are grinding against each other without protection, causing reduced pump output, loss of hydraulic pressure, and premature pump failure. On the other hand, The high-performance lubricant meets the J20C spec for Brookfield viscosity and flows well at both hot and cold temperatures, which translates into improved efficiency and pump performance in all weather conditions.
The next category for J20C specification is Oxidation Stability, which shows the ability of the lubricant to keep parts clean. John Deere requires lubricants to meet a maximum viscosity increase of 10%.
The high-performance fluid tested easily met this requirement at 1.4%, but the low-quality fluid failed miserably at 24.9%. Low-quality fluids cannot prevent oxidation, which causes the formation of deposits on metals, bearings, and seals, as well as the thickening of fluids. Deposits and thicker fluids will strain hydraulic pump systems for premature equipment failure. However, oxidation protection characteristics found in high-performance tractor hydraulic fluids keep parts clean, providing optimal performance throughout the fluid drain interval.
The final requirement of the J20C specification is for fluids to pass the JDQ95 wear test. This 50-hour test is used to evaluate the lubricant's load-carrying, wear, and extreme pressure characteristics in spiral bevel gears.
You can see that the low-quality fluid tested did not measure up, leading to severe wear, ridging, and scoring. Parts protected by the high-quality fluid show little to no wear.
So, you've seen the evidence. It's clear that low-quality tractor hydraulic fluids do not meet OEM credentials and performance claims. While they might say they do, many of their claims offer obsolete and outdated specifications. Until now, it's been hard selecting fluids you can trust. The TractorLife.com authenticated mark makes it easy. Fluids endorsed by this mark meet and often exceed OEM credentials, providing optimal tractor performance today while making downtime a thing of the past.
A hydraulic system, however big it may be, works by moving the working fluid through the components. But apart from power transmission, a hydraulic fluid additionally helps in dissipating the heat from components, thus cooling the system. The heat generated is due to the working of various components. To ensure smooth functioning, the moving components of the system should be lubricated as well. Thus, hydraulic fluid has various functions in a hydraulic power system. The selection of hydraulic fluid is dependent on the requirements of the power system. Nonetheless, the hydraulic fluid must possess some properties to be used in a hydraulic power system. Let's discuss some of these properties. First of all, the hydraulic fluid must have good lubricity. This is because if the surfaces of various components come in contact, then it may cause wear and damage to the system. Thus, a hydraulic fluid having good lubricity separates and lubricates the components effectively. Now, as the hydraulic system performs work, the temperature of the system rises, which affects the viscosity of the hydraulic fluid. On increasing the temperature, the viscosity of the liquid decreases and vice versa. This change in viscosity due to temperature is measured by the viscosity index of the fluid. A hydraulic fluid with a low viscosity index will have a large change in viscosity with the corresponding change in temperature. On the other hand, a fluid with high viscosity index will have a small change in viscosity. The next property is the overall stability of the hydraulic fluids. Now, what is this stability? In a hydraulic system, the fluid is subjected to various conditions like large pressure and temperature variations, turbulence, and contamination of particulates. Thus, a hydraulic fluid should be stable chemically as well as physically to ensure usage for long time periods. Moreover, the compatibility of the hydraulic fluid with the system is a must. Otherwise, the hydraulic fluid may damage the parts by reacting with them, thus losing its functional efficiency. As we have seen in our previous videos on fluid power, most liquids like oil or water are considered incompressible. Although, in practice, all materials are compressible to a certain extent. The bulk modulus of a liquid is the measure of compression with an increase in pressure. A material with high bulk modulus will undergo lesser compression as compared to a material with low bulk modulus. Therefore, the hydraulic fluid must have high bulk modulus for proper working. Another property desired in a hydraulic fluid is fire resistance. Since most of the hydraulic oils used are petroleum derivatives, care should be taken while operating them. Otherwise, the fluid might ignite at high temperatures. To overcome this, synthetic hydraulic fluids having high fire resistance are used. When you mix liquids and gases, you might have seen the formation of foam. Liquids can absorb nearby gases, and foam, which is just gas trapped in the liquid. If the hydraulic fluid has the tendency of forming foam, then it can cause leakage of hydraulic fluid and damage the system. Thus, hydraulic fluids having low foaming tendency are preferred in hydraulic systems. Well, apart from all the properties we have seen, hydraulic fluids should also be able to prevent rust formation in the system and dissipate heat effectively. Although, no hydraulic fluid can possess all the properties. Hence, the best possible hydraulic fluid is used which fulfills most of the requirements of the system. Well, that's all for the properties of hydraulic fluids.
In this video, we're going to talk about how to select a hydraulic oil for your application. So, one of the easiest ways to think of all the different hydraulic oils is in the way that formulators think of them when they formulate the different products. Two of the major ways that they do that is to look at two of the formulation dimensions, which would be the quantity of zinc in the formulation as well as the viscosity index. Rather than putting them on a continuum, I'm going to make this simple and divide it into kind of 4 quadrants. So we've got standard VI and high VI on the x-axis, and zinc-based anti-wear packages versus zinc-free anti-wear packages. So this will give us a bit of a framework to talk about the different options. As you travel from the bottom left to the bottom right, the formulation gets a lot more difficult to achieve some of the OEM requirements. So you can imagine once you can't use zinc-based anti-wear additives, you've got to look to other alternatives. These are often more expensive, but it also makes it more difficult to meet the criteria of, let's say, the Bosch Rexroth test. So, question 1, why do you need to go with a high viscosity index hydraulic oil? 2 cases in which you would do that. Firstly would be if you're operating under a wide ambient temperature range. So I see this a lot in the wind industry, for example, where some of the more remote locations, in the middle of winter, they can get to, minus 30, minus 40 degrees Celsius. And in summer, it might be in the 30, 40, 50 degrees Celsius. So that wide ambient temperature range means that on startup, you need a really wide, a high VI to be able to cope with those conditions. The other one is a wide operating temperature range. So if you have something which is going to start relatively cold, but obviously work at a reasonably high temperature, then you need, again, something with a decent amount of VI in it so that the viscosity is not going to change dramatically over time. I've put this chart up a couple of times, and basically if we were to go to a higher viscosity index, your viscosity at 40 degrees Celsius is the same, but it would maintain more viscosity at a higher temperature. And that would be, desirable. Particularly, we see wide operating temperature ranges. In the hydraulic space, it's now all about reducing the size of the hydraulic pack. So as you reduce the size but put more power through the pack, that's going to mean more heat. And that's just part and parcel of the designing of the system. So as all the hydraulic packs get smaller and smaller, we tend to see higher temperatures, and that's really driving a lot of lubricants to go to a high viscosity index. Now, why would you go for a zinc-free hydraulic oil? So zinc-based ones tend to be the cheaper ones. So it's really, why would you go the extra step and select a more expensive hydraulic oil? First would be if you have aquatic toxicity requirements. So if you're working over water, for example, or in and around water sources, this might be a desirable trait. So if you're working anywhere near, let's say, a harbor, or if you're working in the hydro industry, so around hydro turbines, hydraulic oils often operate the gates there. Zinc-free also helps you with keep clean performance. So one thing that's probably worth noting is that sludge in hydraulic systems is the most common component of that sludge is actually broken down ZDDP additive. So after it's performed its function, it goes to sludge quite easily. So having a zinc-free formulation really helps you with keep clean performance. Now, the detergent is also going to do some of that work, but not having zinc in the initial formulation is really going to assist the lubricant in maintaining that clean performance. If you've got close tolerance components like servo valves, then obviously having any kind of varnish or sludge in the system is going to make them prone to sticking. So again, that's a driver to go zinc-free. And if you have high temperature operations, the reason we say this is because the ZDDP additive, it breaks down, it's a thermal degradation mechanism which causes ZDDP to break down. So once you go kind of into that 100 degrees Celsius range, probably really anything more than about 80, ZDDP starts to break down and go to sludge. So again, if you're having those high temperature operations, you really want to start looking at zinc-free alternatives. And that really means mobile equipment. So zinc-free is often a recommendation when we go to mobile equipment, simply because a lot of the mobile equipment OEMs are putting more power through smaller hydraulic packs. As a consequence of that, you're getting higher temperature, and therefore it drives a need to go to a zinc-free package. So really those last 4 points are kind of linked. Mobile equipment is going to mean higher temperature, close tolerance components, and a need to keep the system clean. So if you were to look at this matrix, I guess what you could probably say is that where you would probably use a standard VI zinc-based product, so that's the cheapest out of all the alternatives, is in systems where you have high losses. So maybe you haven't got a handle on leaking hoses and things like that, but you can afford to lose a lot of hydraulic oil, so you use it as a consumable. Then you just need a cheap hydraulic oil. If you've got really large oil reservoirs, so the oil's not really working that hard, and if you see mild temperatures, this is a really good reason to go with a cheap, bog standard, conventional hydraulic oil. Where you might need something with a bit more VI is really kind of typical industrial plant uses. It might see a wide operating temperature range, but there isn't really a strong driver to go to zinc-free because you can afford a much larger oil reservoir, and there's no real concerns about it getting to 80 to 90 degrees. It probably operates around, let's say, 60. All right, so as you start to move up the chain, zinc-free with a standard VI, you're probably just using this for the low toxicity requirement. So maybe you work over a water source, right, and you need that zinc-free requirement. And finally, zinc-free and high viscosity index, that's when you might need something with a low toxicity, but it's not essential, where you're going to be either in ambient temperatures that have a very wide range, or operating temperatures that are, have a wide range or at the top end of the range. You have a need to keep it clean, or you have mobile equipment, which sort of encompasses all of that. So there are other considerations, obviously. We're not just talking about whether a hydraulic oil has zinc or not, and whether it has a high or standard viscosity index. Some of the other things to maybe look at on the product data sheet would be things like the tapered roller bearing viscosity loss test. This is actually one which is, I believe it's Kluber that started this test, and it looks at the shear stability of a hydraulic oil. So it's easy to cheat viscosity index, I guess, by putting in a lot of VI improvers. But VI improvers tend to shear down over time. So you want to ensure that your VI is going to stay high for the long run. and this will give you an indication of that. Copper strip corrosion test. So this is one where the lubricant will be subjected to a copper strip, and depending on the results at the end of the test, they'll give you a score based on this rating. That can be, in particular, very useful if you have a lot of copper in your system. So either copper in your bearings in the hydraulic pack, or maybe you have copper oil coolers. This is a really handy test to have on file. Number 3, hydraulic efficiency. So the hydraulic efficiency of different hydraulic oils varies greatly, predominantly down to the quality of the base stock and its interaction with the seals. So you want to check, often they'll do comparisons of hydraulic efficiency with, let's say, quote-unquote, competitor lubricants. It's worth checking that, and if you can, measuring it on site. There's also the FZG test. So this is a scuffing test which is focused on the performance of gear teeth, but in a lot of hydraulic packs, you may actually be using hydraulic oils in geared applications. So in that case, you might want to take a look at the FZG rating. Foam sequence is going to give you an indication of its ability to release foam. So in particular, if you have a very small oil reservoir, its ability to get rid of that entrained air is going to be very important to prevent cavitation. And finally, you've got OEM testing. So your hydraulic OEM may have a very specific set of tests, but it's also worth just looking at some of the other OEM approvals that the hydraulic oil may have achieved. So I'm showing some pictures, for example, of equipment that has gone through the Bosch Rexroth test, which is sort of the gold standard when it comes to different OEM testing. It's probably the one that works the oil the hardest. Now, this one is a really interesting one because it has a really strong focus on wear protection of a vane pump. And as a result, it's extremely difficult for lubricant manufacturers to achieve a passing grade in this test without zinc in their formulation. I think there's only a couple of hydraulic oils that have done it to date. So this is something that looks like it's passed the test. And just to give you an idea, this is what the equipment would look like when it fails the test. So it's a really good, if you like, litmus test of the quality of the lubricant. So all these other considerations are really up to your application. So definitely consider these, but place it, is that going to be relevant for my application? Because you obviously don't want to be spending any more than you have to.
We have explained so far different types of hydraulic system, properties of hydraulic fluids, selection of hydraulic fluids, ideal properties of hydraulic fluids, additives and its types, the effect of temperature and pressure on hydraulic fluid. So, after this lecture, a student will be able to understand the following things. That is, he will explore the different types of hydraulic fluid in fluid power system, identify desirable properties of hydraulic fluid, recommend additives used to enhance properties of hydraulic fluid. So, with this we come to the end of the important topic called as hydraulic fluid. So, in today's class it was full of information wherein we explored different types of hydraulic fluids used in hydraulic and pneumatic system, their technical properties, their commercial properties like lubrication, viscosity, anti-foaming agent, and also we used additives to enhance these techno-commercial properties. Finally, we studied the effect of temperature, effect of pressure on hydraulic fluid because temperature and pressure vary globally. So, with this I will stop at this point of time, and in the next class we are going to start with different types of seals. Thank you.